Number 41. Don placed a ladder against the side of his house as shown in the diagram below. Which equation could be used to find the distance x from the foot of the ladder to the base of the house? So taking a look at this problem, you have a right triangle, and your height here is 19.5. Your ladder is 20 feet, and we're looking for the distance from the foot of the ladder to the base of the house. Since this is a right triangle, you can use the Pythagorean Theorem, and this is your hypotenuse. So you're going to have a squared plus b squared equals c squared. The hypotenuse is your c squared. Okay, and then you can solve your equation from there. Now, if you've also been taught that if you know your hypotenuse, that you can simply subtract, you can do 20 squared minus 19.5 squared. And when you get your answer, don't forget that you need to take the square root of that answer in order to get x, or your distance from the foot of the ladder to the base of the house. Number 42 asks which of these graphs is symmetric with respect to the y-axis. So when you're taking a look at the y-axis, that's your vertical axis. So this is what you should be looking for, or looking at. Now, symmetric means that if I would fold it over that line, that y-axis, that the image would sit directly on top of itself. So taking a look at that, if I folded over the line, the y-axis, A is going to be the one that is symmetric. In number 43, it asks, in the accompanying graph, if point P has coordinates AB, which point has coordinates negative BA? First thing you need to do is take a look at point P. Point P is right here. And its coordinates in respect to your x and y axis is 2, 3. So that's point P. So what they're asking you then is, if you take that and rewrite it here, my B up in point P was 3. So if I make that B a negative and my A was 2, write that down like that. Now we need to find the point that has these coordinates, negative 3, 2. Do that and circle the correct answer. In this problem, it's asking you which value of the graph of the function below is not in the range. Keep in mind that the range, those are your y values. So you're taking a look at all of your y values, and we're looking for the one that is not graphed. So if we're taking a look here, looks like 5 is graphed, 3 is graphed, 2 is graphed, 1 is graphed, 0 is graphed, negative 1, negative 2, negative 4, negative 5. So taking a look at your options, A, B, C, and D, which one of those are not a y value that is graphed? In number 45, it says a cleaning service charges an hourly fee plus a fixed starting price. The cost, which is C, in dollars to clean your house for a number of hours, represented by H, is described by the function C equals 10H plus 50. So which statement is true? A is the cost to clean your house for 2 hours is $60. B, the cost to clean your house for 6 hours is $100. Each hour costs $10, and the fixed starting price is $50. And each hour costs $50, and the fixed starting price is $10. So what you need to do is basically take a look here. A, we're going to take our 10H plus 50. In option A, it says the cost to clean your house for 2 hours is $60. So if I plugged a 2 in here, 10 times 2 plus 50, does that make it true? In option B, the cost to clean your house for 6 hours. So you would plug a 6 in there, 10 times 6 plus 50, is that $100? Does that make it true? C says each hour costs $10 and the fixed starting price is $50. Or each hour costs $50 and the fixed starting price is $10. And those are two options where you're just taking a look at the formula itself and seeing, does this represent the fixed price or the per hour price, and does this represent the fixed price or the hourly price? For number 46, it may be helpful to refer back to problem number 36, where I showed you and taught you how to use the graphing calculator to enter in to the stat button and edit a list and put in all your x and y values here. Once you do that, in number 36, I taught you how to do the calculations of a linear regression, which will give you your y equals mx plus b, or that equation that you're looking for in part A here. So take a look back at number 36, follow the directions, that'll give you what A is, and then you have to interpret, is water entering or leaving the tank, how much water is left in the tank after 3 minutes, and basically what you're just going to do is use this 3 minutes in the equation that you have in part A. Find the slope, describe its meaning. That slope will be given to you in part A. And finding the x and y intercept. So if you would graph this line, where does it cross the x-axis and where does it cross the y-axis? And what do these quantities describe in relation to the water in the tank? When you're finished with number 46, pause the video and get all of these answers, A, B, C, D, and E, checked by Mrs. Jones. In number 47, you see 4 graphs listed there. It says, which graph does not show y as a function of x? Remember that in order to determine a function, you can do a vertical line test on all of these graphs. Now, what that means is that you're going to draw vertical lines. For example, on your xy axis, you can take and draw vertical lines. If the function that is graphed crosses these vertical lines only once, then it is a function. If it crosses more than once, it is not a function. In number 48, take a look at the drawing that is given. You need to determine if it is skewed, uniform, or symmetric. I have given you 3 rough drawings here to kind of give you a visual of what a skewed, uniform, and symmetric graph would look like. In number 49, it's asking what is the probability of rolling at least 1 6 on a pair of dice. So first of all, it's important that you identify that you're talking about a pair of dice and not just a single die. So when you take a look here, okay, right here, we're talking about our total combinations. So there's 6 possibilities on the first die, and then there's 6 possibilities on the second die. So you multiply them together, and you get 36 total combinations. The next thing you have to identify are the combinations that you could roll that has at least 1 6 in the combination. So for example, I've listed them here. You could have a 6 and a 1, a 6 and a 2, a 6 and a 3, and so on and so forth. The formula for probability is the number of successful over the number of total. So knowing this information, how many successful combinations have at least a 6 in them, over how many total combinations. And if it's possible, you need to reduce your fraction. In number 50, there's 2 box and whisker plots shown, and they show the scores for a math exam for 2 different classes, Class A and Class B. What they're asking you for is to take a look at their interquartile ranges. And what does it tell you about the two classes? Remembering what a box and whisker plot represents, the spot down here at the very end represents your minimum, or the lowest number. The max is up here, that's your highest number. And then here you've got your quartile 1, or your lower quartile, and quartile 3, which is your upper quartile. Where it sits on the number line here is your median, or when your numbers are all lined up, the very middle number. When you ask about interquartile ranges, that means you're going to take your quartile 3 minus your quartile 1. So you'll need to do that for both Class A and Class B. So look at your box and whisker plots for Class A, identify where it's sitting on the number line for the quartile 3 and quartile 1, subtract them and get a score. Do the same for Class B, and then you'll have two pieces of information that you can look at to determine which class performed better.